Good morning, everyone, and welcome to Temple's webinar, where we'll be discussing environmental monitoring and the benefits of environmental monitoring and what that means for mitigating and management of any risks. Just a bit of housekeeping. If people who aren't speaking, if they could put their cameras off and mute themselves, this just helps with any sort of bandwidth problems or any disruption. And then when we do have the speakers, if they could then put their camera on, that'd be great. So my name is Rena Halford. I'm an Associate Director here at Temple Group, and I look after the Environmental Management and Consents team. But we have a number of speakers today. We have Luke, who will be talking a little bit about general environmental management and why it's important for monitoring. And then we have speakers from our air quality and noise team, Daniel, as well as Richard, who will be going through some of the main elements with regards to that type of monitoring. Thank you, Meg. So who are we? Oh, if people could mute themselves, that'd be great. Not to have any background, thank you very much. So Temple, we are an SME. We work within the environmental sustainability sector, and our purpose really is to make sure that we have an ethical business, but also that we put our clients at the centre of our business for that. Next slide, please. In terms of our vision, purpose and mission, we are very passionate about creating sustainable futures and also making sure that we have a meaningful environmental and social difference together. So we see ourselves as leading in that market space in terms of innovation, inclusivity, and also looking at different sort of sustainability methods and management to provide that positive change really for the clients and the projects that we work on. Next slide, please. So as I mentioned, with an SME, we don't tend to do the engineering or the design side, but we are specialists in environmental planning and sustainability. We have a number of offices throughout the UK, London being our headquarters. And we, as well as sort of with the clients that we work with, we also partner with other companies which have the same sort of ethics and the same sort of values that we also portray. Next slide, please. So just a bit of an overview really to our services. We have a number of services, from technical services such as air quality, noise, ecology. Also, we have a broader sort of environmental management and consents piece. We do the whole life cycle of projects, from EIA, pre-consent activities right through to delivery and post-consent. And we also have a digital delivery team focusing on GIS solutions, as well as a town planning and social value team as well. We tend to sort of work along a different type of sectors, so infrastructure being our main bread and butter, but we also do work in other services such as property and energy and water. Next slide, please. Just a note that this webinar is also part of our IEMA quality mark commitment. So we work with IEMA to look at how we can produce sort of EIA projects across the piece of what we work with. So this is just sort of a webinar to understand, I suppose, the monitoring elements during the pre-consent status, and also how we sort of lead into the post-consent and for monitoring, and what that means for environmental management. Next slide, please. Okay, so that's just an introduction. If we could also have a Q&A session at the end of the session, that would be great. So if you do have any questions, keep them to the end. And if you could put up your hand when you do have a question, that'd be super, and we can go through those then. But without further ado, I shall hand over to Luke, who will go through the environmental management and consents part of the monitoring.
Okay, thank you, Ryan. So hi everyone, my name's Luke Bajic. So I'm a consultant here at Temple in the Environmental Management and Consents team. So I'm going to talk to you a little bit today about environmental monitoring and some of the reasons why it's necessary on construction sites. So we can just flick to the next slide, please. So question, why do we monitor construction activities? Next slide, please. Okay, so these are the topics for discussion today. I think this slide gives you a bit of a clue to the answer to that question. We're going to run through these key topics in the next 10 minutes or so. And hopefully by the end of the slides, we'll be able to summarise the value and importance of environmental monitoring. So next slide, please. Okay, so the first key point I want to address is legislation. Environmental monitoring is often a legal obligation. So that may be, for example, under an overarching legislation, such as the Control of Pollution Act, which requires us to manage noise effectively on construction projects. This act usually dictates the use of best practice, which is often in the field of noise, controlled through a Section 61 consent. So environmental monitoring ensures compliance with such legislation and the regulations and permits which may sit underneath this. Next slide, please. Thank you. So under planning legislation, conditions are often written into a decision notice for the approval of a construction activity, such as the development of a block of flats, for example. So certain conditions in the planning permission will require discharge prior to the commencement of that project. Now, in order to discharge some of these conditions, the local planning authority may be required to approve certain environmental management plans, which may include a construction environmental management plan, known as a SEMP for the activity. Now, the SEMP provides a structure to ensure that environmental issues are effectively managed and to ensure a systematic approach to environmental management. So as part of these management plans, such as a SEMP, environmental monitoring requirements will be outlined and specified in order to mitigate against nuisance. So key nuisances that we're addressing in this webinar are air quality and noise, so dust I've focused on, as well as other potential pollution incidents. So a SEMP may state something such as particulate matters will be measured and trigger levels set. So a statement such as this will have been submitted to the local planning authority as part of a management plan, and that will be in order to discharge a condition planning permission to subsequently commence works on site. So you can see how it all knits in and works up to that ultimate planning permission. Next slide, please. Okay. In the case of breaching any of the legislation, regulation and conditions mentioned, enforcement action may be taken by a range of regulatory authorities. So in the case of, for example, on this slide, I've used the Environment Agency as the regulatory authority. So the Environment Agency publishes, or has published previously, a series of pollution prevention guides, which is the PPG you can see on your slides. So essentially, as quite clearly stated, they're a series of guidelines on how to avoid pollution. But if a pollution incident does occur, the Environment Agency may fine an individual or a company. Now, these fines reflect the seriousness of the offence and the financial circumstances of the offender. So there's no blanket fine for, say, a set offence. And as stated, it's linked to company turnover, harm, or culpability. Now, these fines can vary from hundreds of pounds to multi-million pound fines in very extreme cases. So just to run through a couple of examples with you on the financial implications that may come from enforcement action. So a company was recently fined £6,000 in order to pay over £4,000 in legal costs, and that was after pleading guilty to breaching environmental permitting regulations. In this instance, that was for causing trade effluent to enter freshwaters without being authorised by that environmental permits that's required. A more extreme example is 3 men in a haulage company were recently ordered to pay more than £260,000 in fines and costs. And that was for illegally dumping more than 60,000 tonnes of waste. And I believe that was on 2 farms. Although this might not directly relate to a construction site, it's an important point to highlight the responsibility of contracting proper waste carriers, as fines and legal implications can continue up the chain. And that's where that key quote comes in. So it's important to note that ignorance is never a defence, and all parties in the chain can be prosecuted. So clearly enforcement action can bring on high unexpected costs, which can be multiplied if enforcement action leads to site inactivity. And this might be, for example, while non-compliances are investigated or any potential pollution incidents are remediated. Now, not all enforcement action leads to direct financial penalties. An example of an indirect financial penalty linked to the point around that site inactivity is a road project in central London several years ago. Now, they continually breached their Section 61 consent, which we mentioned earlier under the Control of Pollution Act, which relates to controls on noise and vibration. So the council provided warning letters that weren't abided by, and then subsequently placed a Section 60 notice on the project. And this limited the working hours down from 8 hours a day to just 45 minutes per day for the piling activity that was responsible for those noise breaches. Now, clearly, this has a significant impact on programme and subsequently costs. So environmental monitoring is a vital part of avoiding that enforcement action. Next slide, please. Thank you. Aside from simply avoiding enforcement action, environmental monitoring may be required under certain contractual agreements with a client due to, for example, stakeholder agreements or client minimum environmental standards in line with an accreditation such as those under ISO. For example, ISO 14001 requires evidence of continual improvement, for which environmental monitoring provides that data set and evidence. Sometimes a client in an urban environment may also require the monitoring of activities due to the sensitivity and proximity of nearby receptors, and that's in order to manage the risk of nuisance and potential complaints and reputational damage, which may subsequently follow. And we'll come on to nuisance in more detail on the next slide, please. Thank you. So as we've just alluded to, environmental monitoring may be required to manage nuisance associated with construction if receptors are in close proximity or a sensitive location, for example, downwind of the site. As you're aware, plant on construction sites can cause health issues to those nearby, be that through noise or air pollution, if steps are not taken to mitigate the risks. So environmental monitoring allows us to predict through the collection of data where issues are arising, and then allows us to put in place mitigation measures to protect the community before the issues get out of hand. So a good example of this would be maybe a particularly dusty activity, such as a certain material being cut. And maybe that's taking place outside in the open on site currently. So without environmental monitoring, the activity may continue to take place for several days, weeks, or even months, allowing the complaints to build up and potentially, as a worst case scenario, long-term health issues for sensitive local receptors. However, with environmental monitoring, a real-time alert goes off as soon as the activity breaches the trigger level, and the activity can be instantly shut down whilst a mitigation measure, for example, something as simple as just moving that activity indoors, can be established. So hopefully, due to early warning, this would mean no complaints and no harm to local receptors. So another point to make is that environmental monitoring allows a method to manage complaints. So with that background data we can collate, we can easily establish if a complaint is accurate or technically justified, and this is a useful tool to take to stakeholder forums. However, it's not just sensitive receptors environmental monitoring can benefit. It's also a benefit to those working on site who can be confident of a safe environment with proper monitoring in place. Next slide, please. Okay, so we've touched on a couple of these points under nuisance management. So environmental monitoring allows that real-time alert, meaning we can respond to an incident, such as the dust example I previously mentioned, with targeted mitigation before complaints arise and before ultimately environmental damages occur. So by monitoring activities, we can understand which activities are high risk, and this understanding can inform current and future construction methodologies. And monitoring data always allows that continual improvement to those methodologies, which in turn demonstrates contractor responsibility. And demonstrating contractor responsibility, again, in turn, manages that reputational risk to the client. Next slide, please. Thank you. However, it's not just about managing reputational risk. Environmental monitoring can also be seen as an opportunity. Environmental monitoring, demonstrating that environmental stewardship, can actually boost future opportunities and tender bids. So this can especially be the case if the contractor uses examples of going above and beyond to attain environmental awards. And in order to do that, monitoring data will be crucial in providing evidence. So an example will be the Green Apple International Awards, and they aim to encourage the efficient use of resources, enhance the competitiveness of organisations, and support the wider goals of sustainable development. Next slide, please. Okay, so to spin back to the original question, why do we monitor construction activities? So I think this slide summarises 4 key points. So monitoring aids in remaining compliant with control measures required to carry out the project, managing and mitigating against potential nuisances, pushing continual improvement with those repeat measurements over time and that bank of data that we can collate, and ultimately demonstrating environmental stewardship. I think most importantly, environmental monitoring allows construction sites to help maintain good relationships with their neighbours, which ultimately benefits contractors in their aim of being awarded future works. Thank you for your time, and we look forward to answering any questions you might have at the end of the webinar. But for now, I'd like to pass you over to Daniel, who's going to talk to you about air quality monitoring in some more detail.
Thanks for that very much, Luke. So next slide, please. So today we're going to be discussing how you can, as a construction site, reduce emissions to air through dust and emissions risk assessment and mitigation. And then we'll talk in more detail about monitoring at construction sites and at remediation work sites. Next slide, please. So the requirement for mitigation and monitoring at construction sites is often determined within an air quality assessment that might be submitted with a planning application, or in order to discharge a planning condition, you might have to produce something like a dust and air quality management plan or relevant sections of a SEMP, which Luke was referring to. So air quality assessments or a dust and air quality management plan will typically include a dust risk assessment with the risk category used to determine proportionate mitigation measures and then inform the monitoring strategy. While the Mayor of London has published guidance applicable to the Greater London area in 2014, most other local authorities across the country haven't adopted their own guidance, and so dust assessments and mitigation measures monitoring requirements are typically recommended in accordance with equivalent guidance documents issued by the Institute of Air Quality Management. The guidance recommends a suite of mitigation measures, and these can cover things from covering and seeding stockpiles to stop dust being generated in the first place, through to steps which management should take to enforce mitigation measures, but I haven't gone into too much detail about this in this presentation. It should be noted that monitoring is typically required to monitor emissions from general construction activities, but mitigation of emissions from plant and vehicles can also be recommended. So, for example, in London, and other local authority areas, including Warwick, you might have to implement requirements on non-road mobile machinery to make sure that they meet prevailing legislation and on emission standards, and these can vary in London in the different sorts of places. Next slide, please. So monitoring should be undertaken to confirm measures to control dust and particulate matter, or PM10, generated at construction sites is sufficient and shouldn't be used to replace mitigation measures. The consensus for a low-risk site following assignment in the IEQM guidance is that visual inspections are sufficient, but continuous monitoring, whether using reference or indicative measures, is recommended in guidance at medium and high-risk sites in London and at least high-risk sites in assessments where the IEQM guidance applied. The London guidance recommends that monitors should be located either along transects so that you can compare upwind and downwind concentrations, or near sensitive receptors such as local residences. Ideally, these would be relocated as work progresses, so for example between different phases of a development as it progresses. So while reference method monitors are available to give precise measured pollutant concentrations, a new monitor can cost upwards of £10,000, and the main purpose of monitoring at a construction site is often to identify when dust from site activities or stockpiles is causing an impact above the baseline so that you know you then need mitigation. So indicative instruments often have acceptable precision to show the trends in PM10 concentrations over time, and therefore they're suitable for this sort of purpose. They're also a lot cheaper and are available to hire for a lot less money, and so these are more frequently used. Temple have historically used turnkey Osiris units, and these monitor for total suspended particulates PM10 and PM2.5, and they send messages in near real time to site personnel when trigger thresholds are exceeded. But we're also investigating there are all sorts of other monitors on the market, and we're actually investigating those now and seeing how they work in comparison. Anemometers can be installed to measure the wind speed and direction, helping to confirm how much dust is actually generated on the site rather than off-site. So at the monitor, if you have an anemometer and the wind is coming from an off-site direction, then you know the exceedance might not be attributable to site activities and vice versa. Having had experience across multiple construction sites, including in connection with HS2, we know the Osiris units are relatively lightweight and all sorts of other indicative units the same, and can be fastened to site hoarding or similar to ensure that monitoring takes place at the desired height. We typically recommend, for those of you that are interested in a bit more detail and how it might work on construction sites in practice, we do typically recommend running instruments on mains power, but a lot of instrument providers sell off-grid power packs such as solar panels or batteries and so forth. So there are options where a main supply really can't be provided. We do have to think about logistics up front as well. They're required, again, to make sure that the power supply can be provided, that you're monitoring at the right height, for example, above the site hoarding, as you can see in the photo at the top there, and in a position that would enable free-flowing air around the inlet so that it's not affected by sort of shielding from hoarding, etc. Some monitors will actually require site visits to undertake QA/QC on a regular basis, such as once a quarter, and many will need sending for annual calibration. But the disadvantages of actually using sort of real-time instruments is that indicative instruments is that PM concentrations can be based on assumptions about particle characteristics, and these might vary spatially, temporally, and during foggy weather. So they're not necessarily going to be accurate, as I was saying, highly precise, as I was saying earlier. The concentrations are therefore only indicative when you're measuring compliance against air quality objectives, if you're looking for those specifically. And they'll also give only indicative concentrations against site action thresholds, such as the 190 micrograms that you can see there on the slide. That's something that's quoted in IEQM guidance. As mentioned already, they might also require a power supply, and security on site is important to make sure they don't go missing. Other methods include passive monitoring. So this will either involve the collection of dust on a horizontal sticky pad during an exposure period before being submitted for lab analysis in a sealed case. And you can see an example there in the second photo. Or it might involve the collection of dust in an inverted cylinder, which is then washed during a site visit by an engineer or similar into a 5 or 10 litre collection bottle, and that bottle is then submitted for lab analysis. Depending on the method used, you might be looking to do that every 2 to 4 weeks. And you can get different types of analysis as well. So analysis might be gravimetric, where the dust is weighed to calculate a dust deposition rate, and that can be compared to a site action threshold in the IEQM guidance. Or alternatively, you might calculate the absolute area coverage and the effective area coverage. The AAC measures the percentage of the sticky pad upon which dust is present compared to a clean reference sheet. And the EAC is a measure for how dark the dust on that sample is. So the EAC is particularly useful because if you're looking to measure the impacts of dust on amenity off-site, or for example on cars or local windowsills or whatever it happens to be on the road, then people are going to be more concerned about dust you can actually see compared to lighter shades of dust that you can't see. To compare the AAC and EAC, there is a matrix that we use that's referenced in guidance from the IEQM, and this can determine a potential dust impact risk, i.e. the likelihood that it could start to cause complaints. You can also request directional analyses to see whether the dust generated has come from upwind or downwind. Depending on the type of sample you take, it can cost between £15 and £40. So, you know, we're talking a lot cheaper than the sort of indicative real-time monitoring that I was referring to. And it can be more cost-effective sometimes, even when you factor in site and travel time with the need to actually change over the samples. They provide an indication of the potential loss of amenity and the effectiveness of mitigation measures, which can be used either on their own at lower risk sites, as assigned in the IEQM guidance, or to supplement continuous monitors at some of the higher risk sites. But the time resolution of monitoring is a significant disadvantage, because if you're only getting samples every 2 to 4 weeks, for example, you might not know necessarily what caused that large level. It's also important to remember that because you're looking at the results retrospectively, you can only then see whether site management practices are adequate retrospectively and make corrections for future monitoring periods. So it might not actually be that helpful if you're not quite sure what the cause of the concern is, but obviously is a lot more helpful if the same sort of thing is going on all the time at a specific area of site, like stockpiles might be in the vicinity of some residences and you've got a monitor in between them. As I was saying, that there are custom and practice site action thresholds that are used for this purpose, so that's quite effective. I want to reiterate as well that for this sort of monitoring, because it focuses on the effects on amenity, you wouldn't be able to determine the risks on human health using the passive monitoring. You would have to go for an indicative or reference method monitors. We have actually used dust soiling gauges at sites around London. There was one where there was an engineering works in connection with the Thames Tideway Tunnel, for example. We had some up there. Finally, when planning conditions are set requiring a dust or air quality management plan, in those dust and air quality management plans, there's often a requirement to report to either site managers or the local authority at a certain frequency. And this might be, for example, monthly or quarterly. It's also, of course, really helpful to site managers if they have those results provided to them regularly in an understandable format, so that, as I was saying, they can then take appropriate measures in future to mitigate any impacts. Next slide, please. At some sites, such as a house builder's residential site that we're currently working on in Plumstead, you might want to monitor for contaminants that might be exposed in contaminated soil as earthworks commence. Where a site is found to be contaminated, you'll often find a geoenvironmental consultant will prepare a remediation method statement, and this might recommend that precautionary air quality monitoring is undertaken at the site boundary. This will either be where there's a potential for volatile organic compounds to be generated, such as benzene, toluene, ethylbenzene, and xylenes, and they can have an impact on human health if inhaled. Or alternatively, you might get certain compounds that volatilize or are mobilized as earthworks commence. At the site in Plumstead I was referring to, we've been undertaking VOC monitoring at the site boundary and at off-site locations using 10x tubes. It's important to arrange for speciated lab analysis because some VOCs will have lower thresholds for detection and the impacts on human health than others. They're quite easy to install because they can simply be fastened with a clip to a lamp post and left in sight for sort of a 2 to 4 week period. And of course, that means you just come and change them regularly, submit them for lab analysis. They're relatively cost effective for this purpose. As I was saying a moment ago, it's also possible for compounds which may be agitated during construction work, such as polycyclic aromatic hydrocarbons, to be released. And while these can be detected using specialist equipment, because they are often sort of exposed as soil is excavated or otherwise mobilized, then having a dust monitor at the site boundary, will tell you when there's too much dust, and therefore you can then start to take action to control dust. And of course, in doing so, you'd hopefully then be controlling the amount of other substances that are released. So I guess it does depend on the severity of potential impact as to whether or not you'd need to consider that sort of thing further. Whilst, of course, you might get asbestos fibres in certain sites that require remediation, I haven't gone into any more detail about them here because that's typically undertaken by an asbestos specialist. So that's it regarding the air quality section. We're now going to move on to Richard, who can talk a bit about noise.
Thank you very much, Daniel. Hello, everyone. I'm Richard Evans. I'm a consultant in Temple's Noise and Vibration or Acoustics team. And I'm going to cover some of the practical on-site elements of monitoring that we've just talked about. I specifically work on noise and vibration monitoring, but because we offer noise, vibration, and air quality monitoring, we very often do the work in tandem. So I'm covering both of those angles here. If I could have the next slide, please. We've worked on a number of projects of different scales, and a lot of this work is scalable to different sizes of work. So for some examples, so as it says there, we generally recommend, particularly for noise and vibration, remote long-term monitoring, because it means you've got 24/7 data on the site. We can set trigger levels to alert when limits are about to be exceeded or have been exceeded, and then we can also report data. We have a lot of data that can be analysed if needed. In terms of the scale of monitoring, we can cover anything from a small site. So, for example, a small construction site, like a current example we have at the moment, has one noise monitor, one vibration monitor, and 1 or 2 air quality monitors on the site. We've also worked with larger sites where they can have up to 3 or 4 of each noise and air quality monitor around the site. And then we've also worked on some very large infrastructure projects, for example, HS2, where on that particular project we had 53 noise monitors, 18 vibration, and 40 or more air quality monitors at any one time, which enabled a lot of data capture. They were all based on specific sensitive receptors, but that gives you an idea of the scale that is possible with the remote monitoring technology. Could I have the next slide, please? So as Daniel mentioned, with noise and with air quality, there are various ways of installing the monitors. So this is an example of what the large project I mentioned there, where we used a lot of public lighting columns, lampposts, And you can see in those two photos, we've got an air quality monitor and a noise monitor sharing the same power supply, sharing the same lamppost, and they were both serving for the same sensitive receptors. Can I have the next slide, please? As another example, you can monitor at the sensitive receptor itself, as we're doing here on these rooftops, where we're just using the railings of the rooftops to attach the air quality and the noise monitors to the railings there. And that gives you the benefit, obviously, that you've got monitoring directly at the sensitive receptor itself. Can I have the next slide, please? And then what we also typically do in construction monitoring is actually monitor at the site boundary. So these are two examples of monitors that are attached to the site hoarding. So in both pictures there, actually, you can see the one on the left, we've got an air quality monitor and a noise monitor with a weather station attached to it, right, installed on the site hoarding next to each other, and the same in the picture on the right. They're installed on the same hoarding. Daniel may have mentioned this, but one of the reasons we've got access to weather stations is that you can get weather data that primarily, I think in that instance, we were using for the noise to make sure that wind limits for noise measurements weren't exceeded, and precipitation limits. But I believe that can also be used for the air quality as well. So that's an integrated solution that worked with that particular noise monitor. So we'd have access to weather data at certain positions. Can I have the next slide, please? And then here, just another example of a boundary of a site, which just happens to be a fence. So there's a number of ways you can mount noise monitors in various places. If we could have the next slide, please. And there's another example here where a site didn't have a proper hoarding at the time because the work was very dynamic. This I believe was on HS2, and because the project was in a transition stage, or it was moving between different phases, the site didn't actually have a hoarding at that point. So we installed a very temporary installation like this to get some data for the site coming in until they actually had a position where we could properly install monitors on. Next slide, please. So that moves us on to vibration monitoring. So all the monitors we were looking at before were shared noise and air quality locations, and this is just some examples of where we would monitor vibration. And vibration can be quite challenging because if you monitor vibration on a construction site, you're very often constrained for space, and the sensors are extremely sensitive, need to be placed on hard ground, and that means that they need their own exclusion zone around them, and you can't place them near to any vehicle routes or walking routes, or the data's not really very useful to the site. So very often what is done is that we monitor at the sensitive receptor itself, and that means finding a space in a building that's secure, that you can put the monitor into and lock it away, and also that it's not going to be disturbed by footfall or vehicle movement or any other kind of movement. And that's just some examples of different monitors generally installed in basements of buildings, sensitive receptor buildings. If I could have the next slide, please. Yes, and so Daniel mentioned a little bit about this, so I'll just elaborate a bit on power. So of course the monitors all need some kind of power, apart from obviously the passive methods that Daniel mentioned. So we would generally recommend some kind of mains power. So when we're using lampposts, for example, like in that picture, it's easy to take the power directly from the lamppost itself. And on site hoardings, if we're monitoring on site boundaries, we'd usually be looking to tap into the power from the generator or the main, if there's a grid connection to the site, tap into that and use that power. It is possible to use solar panels and batteries, but I know some monitors are more power hungry than others, and it can prove challenging with some of the more power hungry ones. We have successfully used solar panels for certain types of noise monitors. You can run off batteries as well, but the downside of that is that it does require more frequent site visits to replace the batteries. If we could have the next slide, please. Yeah, so that leads on to maintenance access. So as Daniel mentioned in his slides, all types of monitor need regular access for maintenance to fix any issues, but also for calibration, quality assurance purposes. So generally, noise monitors need access every 3 months to calibrate the monitors. I know a lot of the air quality monitors will need 3-monthly access as well. And then monitors also need sending off to a laboratory on regular intervals, either every year or every 2 years. So that's always something that we recommend factoring into a monitoring project, is that the ongoing access will be needed, but also monitors have to be swapped over, and very often a replacement monitor will be needed just for the period when the active monitor is being sent off to a laboratory. And that leads on to forward planning. So it's very useful if at the outset of a monitoring project you can forward plan, and if we can get an idea of what the phases of the development are, where monitoring is going to be needed, and how that is going to shift, if the site boundary is going to change, if the receptors affected are going to change, and if that monitoring is going to need to move around the site. Very useful to be able to plan that in advance, because that can mean that monitors need relocating, or you will need more monitors at some point in the project. Yeah, so part of that is prior planning. So it's just ensuring that there is ease of access, and a lot of that can be done by scoping out where the monitors are going to go before they're installed, and making sure that they're put on the right part of the site if they're on the site, or in the public realm if they're put somewhere where ongoing access is assured. And what we usually do is we try and install monitors ideally so that we avoid working at height or interface with other works on a construction site wherever possible. If I can have the next slide, please. Yeah, and finally, just part of that planning point is when it comes to carrying out the monitoring, it's good to make sure that site teams are briefed and on board with why the monitoring is taking place, and why ongoing access is needed, and why it's important that the monitoring is done effectively. In other words, that we minimize power outages, that we maximize the uptime of the monitors and the percentage of data capture that we get from them, because that's essential, tying into what Luke said about ignorance is not an excuse. Basically, you need the data there to cover your activities, and as part of that, it's good for us carrying out the monitoring to have an active list of contacts at the site that we can get in touch with if there are any problems. Thank you very much.
Brilliant. Thanks very much, Richard, Daniel and Luke, for a very informative discussion around monitoring. Are there any questions from those sessions? No questions so far. Oh, we have one from Philip. Hi, Philip. Did you have a question, Philip? Nope, not quite sure if we've lost you there. We can come back to you, Philip, if you've managed to rejoin. In the meantime, anyone else have any other questions? Okay, so I actually have one for possibly Richard or Daniel. I was just wondering, how often do you get requests for sort of displaying your data and information to resident panels as they respond to any complaints? Do you often get that request from local planning authorities?
I think in general, sort of experience from air quality is that it's often that in many cases it has, or in some cases where we have been commissioned to do monitoring, it has been driven by complaints perhaps being raised either to the site or to the local authority, who have then relayed that to the site. So the site has thought, okay, well, we need to get some monitoring installed. And I suppose the point of having proactive monitoring is to prevent that from happening. So it's not often the case that from what I've worked on so far that you'd have residents panels involved.
Yeah. Okay. We do actually have. Sorry, Richard, do you want to add to that?
I was going to say something similar to Daniel. Yes, we have in the past been asked to provide data through the ultimate client, so they were actually would be doing the engagement. But yes, we have in a number of instances had to provide additional monitoring. So as part of so in addition to remote monitoring, we've been asked to go and do attended monitoring, to send consultants down to a site where there have been complaints and actually be there in person during particularly sensitive work. So that has happened in the past. Yeah.
So you need a bit of a combination of both, really.
It depends on the scale of the project and the various sensitivities. I mean, that's then we're talking about projects where there are a lot of sensitive receptors, and either to preempt complaints or in response to complaints. I think in some instances actually to preempt complaints and to say we are, looking at this activity and making sure it's to best practice, basically.
Yeah, absolutely. Great, thank you. We do have a few sort of comments in the chat. Hi Philip, yeah, I'm not quite sure what happened to the sound there, but your question was around if there's any logistical issues with gaining permission for example, the use of lamp posts, and whether we need sort of any council permissions when we install any infrastructure, and electricians' input. So that's probably to Richard or Daniel.
Yeah, in short, yes, you do. You can't just go and drill into a lamppost without the local authority taking interest in it. So yes, there is an approvals process that you have to go through before you can attach anything to a lamppost, whether it's I believe it even goes as far as the small passive monitoring solutions that Daniel was talking about. But certainly when we're installing something as heavy as a noise or an air quality monitor, there's an approvals process, and the electricians have to be experienced in working on that type of installation as well to use the power from the lamppost. Yeah,
and often in our projects as well, Philip, we do tend to partner with electricians to basically go out on site and do those sort of installations together. But yes, sometimes usually electricians are required. Okay, hopefully that's answered your question, Philip. Okay, any other further questions? No? Last call. Just to say, as Carla's mentioned in the chat, we will make this presentation available onto the Temple YouTube sort of website, so you can get the presentation on there. If there aren't any further questions, we will probably wrap it up there, but just to say thank you to everyone for attending today. Hopefully you found that very interesting, and you can take some of those thought pieces back to your organisations and the work that you do as well. So thank you very much everyone for joining today, and wish you a good rest of the week.